Okay, we will introduce the proposed works. Our works is the label information bottleneck for the label enhancement. We will introduce our work from the five perspectives. The first one is motivation and the contributions. And in our works, the main contribution is we address the problem from the perspective of the information bottleneck. It is different from other works, and we normally introduce the concept of label relevant information to address the label enhanced problem. Okay, we will introduce the proposed work detailedly. The motivation of our work, it can be observed from this image. We can see that if we use vertical labels to describe this image, the sky and the road labels are all labeled by 1. However, it can be observed that the sky described more than road, more 就是 extremely more than road to describe this image. So a suitable way to describe this image is that we use the label distributions. Therefore, the label description degrees can be provided by the labels. We turned the learning process from logical labels to label distributions, turn it label enhancement. Actually, it is unpractical to annotate data with label distributions manually, and most existing dates in the field of computer vision and machine learning are annotated by single labels or multiple labels. They are all logical labels. Therefore, it is promising to recover the desired label distributions exactly from existing logical labels. Let me introduce some existing LE methods. The objective of most existing LE methods, such as GLLE, LESC, GLESC, and LEVI, they can all be consistently summarized as follows. They have the extra term, such as they has the extra term. For example, the GLLE, it needs the extra term from the graph Laplacian, and the LESC and the GLSC, the extra term is from the property of the data self-expressive property. These all exit methods have the limitations that the first is they all neglect the label irrelevant information contained in X, and the second one is that they all require the extraterm D minus L. This is not a reasonable constraint. We can consider that if the road logical label the description degree is so small, then this term can be just get a wrong recovering process. So we bring the new idea for the task of label enhancement. We deal with the LE problem from the perspective of information theory. We decompose the label relevant information into the information about the assignment of labels to instance and the information about the label gaps between logical label and distribution labels. Therefore, it should be noted that rather than simply employing the information bottleneck to the LE task, we further proposed the framework, namely label information bottleneck for the LE task. Let's see the whole framework of label information bottleneck. The proposed framework fully considers the label relevant information during the LE process, provide the X and the logical labels. By employing the label information bottleneck, we can get the desired label distributions correctly. The whole learning process can be seen as follows. The two terms, the L subscribed AS and the L subscribed GP, are jointly running to get a new representation when we contain the label assignments information and the label gaps information. So we can see that the proposed method jointly have the following two process. The first is run the representation with label relevant information, and the second one is that recover the label distributions based on the learned representation. For the first term L subscribed AS, it extracts the information about the assignment of labels to the instance, and the second term L subscribed gap, it investigates the information about the label gaps between the logical labels and the distribution labels. And the last term is the label irrelevant information modeling. So we can see the whole objective of LIB. For the first term, the property of KL divergence and the entropy are positive is employed, and the Markov chain is also used during the optimization process. For the second term, L subscribed gap, we consider the conditional self information here, and it can be also interpreted and derived from the view of the probability distribution. So we can get the whole objective of our work. During the optimization process, the empirical mental Carroll approximation of sampling and the reparameterization trick and the variational inference are also employed. So for we compare our works with existing LE methods. The main difference between LIB and our works is LIB considers the problem from the information bottleneck, and we can deduct the about term by extracting the label relevant information about the label gaps between logical labels and label distributions reasonably. And here are some experiments results on toy dataset and real-world datasets. Thank you for your listening.